Okay, so today we're doing Math Day 2, which is algebra. I call it algebra because that's the way they're going to spell it, that's the way I'm going to say it. Alright, so here's the deal with algebra on your SAT and ACT. It makes up the majority of both tests. Technically it's not the majority of your SAT, because technically it's only 28% of your SAT. But what winds up happening is, even on the other types of problems, they throw in algebra here and there on the other types of problems. So algebra becomes very important on your SAT. Your ACT is 55% of the questions. But you guys who have taken these tests before, you know the algebra on these tests is weird. Okay, it's not normal algebra that you guys are used to doing in school. So we need to find ways to get around it. So our first strategy to get around it is using those picking and choosing strategies that we practiced last time in our math packets. Okay, and our picking and choosing strategy packet from last time. So that's kind of our first way to get around it, but there are times where we can't get around it and we just have to bite the bullet and actually do the math and do the algebra, and that's what this packet is about. What we have to do when we have to actually do the problems. Okay, so basic equation solving down at the bottom. This should be a real straightforward review, hopefully. All right, the first one on your brain exercises, we have 3x minus 4 equals 2x plus 2. Again, hopefully for most of you, this is just a straightforward equation to solve. X is going one side, numbers go on the other. So I'm going to throw the 2x to the left, so I subtract 2x from both sides. I'm going to get x minus 4 equals 2. Add my 4 to the other side, I should get x equals 6. And I'm done. Okay, again, basic equation solving there. Number 2. You got 1 over x plus 2 equals 3 over 5. Okay, so fractions on both sides. There's an easy way and a hard way to do this. Most of you guys have been trained to do the hard way, which is finding a common denominator. That's highly annoying. Don't do that. The easy way to do this when you only have a fraction on each side is just to cross multiply. Okay, we're going to do a lot of cross multiplying in this class, especially when we deal with proportions. So simply cross multiply on your diagonals. 1 times 5 is 5. It can go on the left or the right, doesn't matter which. I'm going to put it on the left. And then 3 times x plus 2. Make sure you get your parentheses in there. Okay? Because you're doing 3 times that whole thing. Distribute your 3. Subtract your 6. And divide by 3. So x is, if you can read my sloppy handwriting, x is negative 1/3. Again, we're going to use that method quite a bit. Okay. We like this because in one fell swoop, from the first step to the second, we're done with fractions, and fractions are done. All right, number 3, we have a root problem. Everybody loves the roots. 5 root x, not equals plus, my fault, try again, plus 14 equals 29. All right. So the first thing to do is to isolate this root, okay? The root is the thing in the equation that's solving us the problem. You always want to isolate the problem. Where's your problem child? Your problem child is the root x. Isolate it. So get rid of the 14, subtract 14 from both sides. We get 5 root x equals 15. Divide by 5. Root x equals 3. Now we can deal with the root. Now we can deal with the problem. How do we undo a root? What's the opposite of the square root, ma'am?
You square both sides.
Absolutely. So square both sides, get rid of it. So over here, the root and my square just cancel. I get x, and 3 squared is just 9. And you're done. Okay. All right, last up is absolute value. For those of you who are in upper level math, like AP Calc, Pre-Calc, Trig, anything like that, it's probably been a while since you've seen absolute value. For those of you who are in like college algebra or algebra 2, this should be a little bit more fresh in your mind. So we have the absolute value of 3x equals 12. Okay. So here's the deal with the absolute value equations. Here's how you kind of want to think about it. We know this has to come out to be a positive. We know that. Okay. So either 3x could be 12. That's definitely a possibility. But what if 3x came out to be negative 12? if this in here came out to be negative 12, when I take the absolute value of it, I'm going to get 12. So that means the stuff on the inside, this 3x, could also be negative 12, because it would still give you the same answer. So I wind up with two separate equations. Okay, all you have to do to solve absolute value problems is take one side, either the left or the right, and make it negative. Okay, so you have one side is written, and one equation that has one side a negative, and it doesn't matter which side. So pick the side that has the least amount of stuff on it, and you have a better chance of not making a sign error. And we're just going to solve the two equations separately. So divide by 3, divide by 3. So in this case, we have 4 and negative 4 as our answers. Absolute value problems will generally always have two answers as long as the side is not 0. If the side is 0, you only have one answer. Okay. Here's the other kicker. It will not always be plus and minus the same number. It may be 2 and negative 7. Okay. It completely depends on what's inside this absolute value. All right. Okay. All right, next page. Wow. On the next page, the first three, SAT number 7, SAT number 5, and SAT number 16. Those are yours for homework. They are exactly like the brain exercises we just did. Okay? So 7, 5, and 16, the first three, boom, boom, boom. Those are all homework. All right. We're going to do number 3. Which of the following polynomials is equivalent to the expression below? We have 5x squared minus 3 times 1 minus x minus 2x times x plus 5. Okay, don't overthink this, guys. This is basic algebra. They want an expression that's equivalent to that. Hopefully your brain looks at that and goes, ooh, I could distribute. So if you can distribute, we distribute. And let's see what happens. Okay? So we're going to distribute this negative 3. We're going to distribute the negative 2x. Negative 3 times 1 is negative 3. Negative 3 times negative x is positive 3x. Negative 2x times x is negative 2x squared. And negative 2x times 5 is negative 10x. Okay. And then just combine your like terms. So 5x squared minus 2x squared is 3x squared. 3x minus 10x is negative 7x. And then I have a negative 3 hanging out. And I believe that's answer choice A. Yes, it is. Okay. Any questions? Because I did that really fast. All right, ACT number 7 at the bottom is yours to do for homework. But real quick question. What does the word sum mean to do? What operation? Add. Yeah, I heard somebody say add. Yeah, so make sure you realize that you're adding those together, okay? I assigned that problem for homework, and I had somebody multiply them together. And that's a lot of work to get the wrong answer, and I felt kind of bad. So now I always double check. All right. These can also come as word problems. So we have two SAT word problems at the top of the page. Note that neither one of them is a calculator problem, unfortunately, which means we're going to do some manual arithmetic. SAT number 2. The formula below gives the monthly cost C in dollars of operating a delivery truck when the driver works a total of X hours and when Y gallons of gasoline are used. Okay. If, in a particular month, it costs no more than $2,000 to operate the truck. Aha. So, $2,000, what letter is that going to go in for? Where's it going?
C.
C. All right, so right away we know C is 2,000. And at least 150 gallons of gas were used. Gallons of gas, is that X or Y?
Y.
Y. If you have trouble with that, use your units to help you. Gallons there. Okay. In the problem it says X hours and Y gallons, and then it tells you 150 gallons. So match up your units. The 150 has to go with Y. What is the maximum number of hours the driver could have worked? So we're looking for X. Okay, so we have C, we have Y, we're looking for X. Plug it in the equation. C equals 10X plus 4Y. Alright, here we go. 2,000 equals 10x plus 4 times 150. Again, non-calculator problem, guys. Manual arithmetic. Start with the 4 times 150. All right, well, what's 2 times 150? 300, double it. 600. So this is 600. Okay. Subtract your 600. 2,000 minus 600. Well, 20 minus 6 is 14. Add a couple zeros. So it's 1,400 equals 10x. And then I just have to divide by 10. If you divide by 10, okay, anytime you're dividing by 10 or a power of 10, the shortcut is to just knock off the number of zeros from your original number that you have in the denominator. So I have 1 0 in the bottom. I can take off 1 0 in the top. So x is 140. And that's how we do that relatively quickly without a calculator. Okay, questions? All right, next one is yours for homework. SAT number 13. Keep in mind that you are working without a calculator on that problem. Again, more manual arithmetic. SAT number 20. Our next dude. Oh, study on. What the heck is that? All right. 2 root 2x equals a. What is 2x in terms of a? So we're starting with that. They want 2x in terms of a. Okay. So we have a choice here. We do have letters in our answers. We could technically plug in a number for a if we wanted to. But quite honestly, that's going to take you a lot longer than just solving this for 2x. So our goal here is to get 2x by itself. That's our goal. So if I want to get this guy by itself, I need to get rid of anything else that's on that same side. So that 2 that's out front, he's got to go. Divide by 2. Root 2x equals a over 2. And I just need to get rid of that pesky root again. So to get rid of a root, we square. So root and squared cancel, and I get 2x equals, so square a fraction, you just square the top and square the bottom separately. So a squared is just a squared, over 2 squared is 4, okay? And then normally I would divide by 2 if I wanted to solve for x, but I don't need to do that here because they didn't ask me for x, they asked me for 2x. So I can just stop here and say that 2x is a squared over 4. So my answer is B. Questions on that, Booger? No. Okay. There's going to be a lot of problems like that on your SAT where you don't have to actually solve the whole thing out. You can stop partway through. So always pay attention to what you're solving for and save yourself some work. All right, last one on the page, number 9. If root 5 is equal to x minus 2, what is the value of x minus 2 squared? All right. This is another one that's real typical of your SAT. Look at what they gave you. Look at what they asked you for. How'd they get there? How'd they go from here to here? Yeah, they just squared it, right? You go from this to this, boom. All they did was square it. Okay? Well, if I square one side, I got to square the other. That's, I mean, basic equation stuff, right? Whatever you do on one side, you got to do the other. So root 5 squared. Well, that's easy. The root and the square just cancel. That's 5. So 5 must be equal to x minus 2 squared. So the answer is 5, and that's part C. That's answer C. Okay. You had very little math involved in that. It's more logic. All right. Break before we do these next ones. These are long. Word problems, everybody's favorite. Okay, so there are quite a few few problems on your SAT, not very much on your ACT, but mostly on your SAT, where you have to develop a linear equation based on a word problem they give you. A lot of students really struggle with this. So I came up with a 3-step process for actually figuring these out. Works great on these tests. Do not apply this to school because step 2 is going to fail every time. 1 in 3 works, but 2 fails. Okay, so the way this process works is you got the steps up at the top of your page. Step 1, you're going to find the same quantity that they ask you for somewhere else in the problem. So if they ask you for a boiling point, you're going to find another boiling point. If they ask you for an altitude, you're going to find another altitude. Whatever they're asking you for, find the same thing somewhere else in the problem. That number should be by itself. It should not be multiplied or divided by anything. Okay? There are times when you can't do that. If you can't do that, then look for the word initial. Anything that's tied to the word initial should also be by itself. Again, not multiplied or divided by anything. Okay? Go to your answers, rule out anything you can just based on step 1. Step 2. All of the numbers in your problem must be in your answer in some form. This is the step that fails in school because they love to give you extra information. So, what do I mean by in some form? For example, if I was given the numbers 8 and 5 in my problem, then my answer choice might have 3 in it because 8 minus 5 is 3. So I'm using the numbers in my problem in some way, adding, subtracting, multiplying, or dividing them to get the number that's in my answer. Okay? But all the numbers in your problem will be used in your answer in some form. Okay, that's step 2. And again, we would look at step 2 and we're going to eliminate anything we can based on step 2. Most of the time you're going to have an answer by the time you get done with step 2. Okay, every once in a while you're going to have to go to step 3, and step 3 is just applying a little common sense. Figure out whether you should be adding or subtracting. Okay, so for example, if you have a plane gaining altitude, you're probably adding. If you have a pump emptying water out of a pool, you're probably subtracting. Okay, so just apply a little common sense to that problem. All right, let's apply this. Let's actually put this into play. So, SAT 14. The boiling point of water at sea level is 212 degrees Fahrenheit. True statement. For every increase of 1,000 feet above sea level, the boiling point of water drops approximately 1.84 degrees. Which of the following equations gives the approximate boiling point B in degrees Fahrenheit at h feet above sea level? Okay, what are you asked to find? We're asked to find B. We're asked to find a boiling point. Okay, step 1. Find the same quantity, another boiling point, somewhere in the problem. What other boiling point did they give you? 212. That number should be by itself. It should not be multiplied or divided by anything. Go to your answer choices. What can you get rid of? C and D. 2 are gone. You're down to a 50-50 shot just with 1 step. Okay. Step 2. All of the numbers in my problem must be in my answer in some form. So, besides the 212, what other 2 numbers are in my problem?
1,000 and 1.84.
1,000 and 1.84. Okay? All of these numbers have to be in my answer in some form. Look at A and B. Which one definitely does not have all 3 numbers? A. There is no 1,000 anywhere in A. So get rid of A. It's got to be B. That ugly decimal is 1.84 divided by 1,000. But even if you don't recognize that, you know it can't be A because there's no 1,000 anywhere in there. Okay? It is not necessary to be able to figure out these equations. You can use this process and be done. Okay, I take graduate level math classes. I looked at this problem and said, I don't want to figure that equation out. I could, but I don't want to take the time to do it. I'd much rather do it this way. Any questions on how we got there? All right, let's do it again. Number 19. On its opening day, a car dealership had an inventory of 29 cars. During the first 6 months, 18 additional cars were purchased by the dealership each week. And the sales team sold an average of 15 cars per week. during the first 6 months. Which of the following equations best models the car inventory C at the dealership T weeks after opening day? Okay. You see how they kept repeating during the first 6 months, during the first 6 months, during the first 6 months? That's just a time frame for the problem. We don't care about that. It has nothing to do with car inventory. So you're going to ignore that. Just ignore the first 6 months. We don't care. It's just a time frame. So, step 1, what did they ask me for? C, car inventory. They asked me for a car inventory. What other car inventory did they give you in the problem? 29. That should be by itself. Should not be multiplied or divided by anything. Did that help us in this case? Not at all, unfortunately. So on to step 2. Step 2 says that all the other numbers in my problem should be in my answer in some form. So besides 29, what other numbers do I have in my problem?
18 and 15.
18 and 15. So I somehow have to get 18 and 15 into this equation. All right. Let's see what we can do. Let's start with number A. That's good. Yeah, let's start with A. So besides 29, I also have a negative t, so that means I have a negative 1, right? Can I get negative 1 out of 18 and 15? No. Adding, subtracting, multiplying, and dividing, no matter what I do, I'm not going to get negative 1 out of that. Okay, so A is out. Rule them out. B, I have a positive 1 in front of my t. Can I get positive 1 from 18 and 15? No. Adding, subtracting, multiplying, dividing, there is nothing I can do here. Okay. So rule out B. C, can I get 3 over 2? If I was going to get 3 over 2, how would I get it? What would I do? Yeah, I would probably divide. It's just bigger number by the bottom. Bigger number by the smaller, right? So let's try it. What does that reduce to? What goes into 18 and 15? 3. So let's divide top and bottom by 3. 18 divided by 3 is 6. 15 divided by 3 is 5. Well, it didn't give me 3 over 2. So C is out. It better be D. Can I get 3 from 18 and 15? Yeah. 18 minus 15 is 3. Okay, so that's got to be D. All right, bottom one of the page, SAT number 1 is yours to do for homework. You will have to go to step 3 on this bottom question. Okay, so you will have to apply a little common sense to that one to get your answer. All right, next page. So those were the ones that are in the right form for us. The majority of the word problems like that will be in the right form. Every once in a while you hit one where the SAT has messed with it, and then we have to figure out what we're going to do. So let's look at those. SAT number 2. A television with a price of $300 is to be purchased with an initial payment of $60 and weekly payments of $30. Which of the following equations can be used to find the number of weekly payments W required to complete the purchase, assuming there are no taxes or fees? Okay, so here they asked me to find W, the weekly payments. But W is not on the left side of my equation in my answers, okay? If you look back at the other problems we've done, in the first one they ask you for a boiling point. B is on the left of every answer. In the second one, they ask you for a car inventory. C. C is on the left side of every answer, okay? In the problem I assigned you for homework, they asked you for an altitude, and the altitude is on the left side of every answer. In our problem here that we're doing, SAT number 2, my weekly payments W is not on the left side. So they've messed with my answers. Okay? When that happens, I have to use the alternate form of step 1. I can't look for the same thing somewhere else in the problem. I can't do that. But I can use that word initial. Okay? Do I have the word initial somewhere in the problem?
Mm-hmm.
All right, what number is tied to that word initial?
60.
That number should be by itself. It should not be multiplied or divided by anything. What can you rule out? D. Let's get rid of D. One down. Okay. Step 2. All of the numbers in your problem must be in your answer in some form. What other numbers besides 60 are in my problem? 30 and 300, right? Okay. So look at your answer choices. What can you rule out? B. Okay, so 2 down. Alright, so we got rid of B, and we got rid of D. We're left with A and C. So we got to go to step 3. We got to apply a little common sense. So if we look back at the problem, what's going on is that they're making payments. And they're trying to get up to that $300 in order to purchase that TV. If you're making payments on something, you're trying to get up to $300, should you be adding or subtracting?
Adding.
You better be adding. Okay, so that's got to be C. So again, just apply a little common sense there, you'll be okay. All right, so we've looked at kind of like what happens when they mess with our equations. Let's look at what happens when they really mess with our answers and they don't even give us equations. That's what the next one is, which is number 11. In 1962, the population of bird species was 2,000. The population K years after 1962 was 48. Killing these birds. K satisfies the equation below. Which of the following is the best interpretation of the number 61 in this context? They are loving these problems lately. Give me the interpretation of this number. So all that means is that that's the number you're shooting for, okay? Our goal in this problem is to get 61. That's our goal. We're shooting for 61. So we're going to look for which answer is going to give us 61. So start with A. Was 61 the population K years after 1962? Go back to your problem. What was the population K years after 1962? No, 48. 2000 was the population in 1962. The population K years after 1962 is 48. So A gives me 48, not 61. Rule it out. Remember, we're shooting for 61. B. Is 61 the value of K when the population was 48? Okay, so what does that mean? Well, if 61 is the value of K, let's go to our equation. That would mean that 2,000 minus 61 times K, which they're saying is 61, would have to give me 48. Now, I'm working without a calculator here, but I'm pretty sure like 61 times 61, well, okay, 60 times 60. 6 times 6 is 36. Add a couple zeros. This is approximately 3,600. So 2,000 minus something around 3,600 is not going to give me 48. So this fails. So B is out. Okay, so B fails. C. Is 61 the difference between the population in 1962 and the population K years after 1962? Let's figure that out. What was the population in 1962? 2,000. Okay. What was the population K years after 1962? 48. Difference means to subtract. Again, I'm working without a calculator, but I'm pretty darn sure that 2,000 minus 48 is not going to give me 61. So we can rule out C. It's got to be D. So D says that the average decrease in the population per year from 1962 to K years after 1962 is 61. Okay. So how otherwise can we prove that? Well, let's take another look at this equation. Fail, I can't copy correctly. That's not good. Alright, this is a really cleverly disguised y equals mx plus b. It's just kind of backwards. Which means that 61 is your slope, it's your m. A slope is a change. It should be an increase or a decrease. And what word do you have in D? The average decrease. Okay. But again, if you don't recognize this, it's okay. Work through your answers the way we did. All right, let's leave the world of linearness for a while. Let's talk about exponentials. Exponentials. All right, so exponential equations have the form f of x or y equals ab to the x. All right, in this equation, A is your initial amount or starting value. B is your growth rate or your decay rate. We generally don't try to calculate B, okay? There's a lot of things that go into it. We just don't mess with it. What you want to know about B is that if B is greater than 1, then you have growth. It's getting bigger. If B is less than 1, you have decay. It's getting smaller. That's a C. That's generally what you want to know about B. We're not going to try to find it. X is typically time, but it doesn't have to be. So sometimes it's time, but it's not always. Okay, now let's look at what they do to these. SAT number 10 at the bottom. The function below can be used to estimate the number of farms f of n in millions in the United States from 0 is less than n, which is less than 72. We don't care about that. Those little like ranges that they give you, the intervals, just ignore them. Where n is the number of years after 1940. Okay, that we care about. Because right there it's telling you when the function is starting. It's starting in 1940. Which of the following is the best interpretation of the number 5.77 in this context? Again, this is an interpretation problem. Our goal is to get 5.77. Okay. So the equation they give us is f of n equals 5.77 something. 0.98 to the n. Alright, so if we write our exponential form right above it, then we can very easily just kind of match things up and see whether our 5.77 is our A, our B, or our X. So obviously, it's our A. We just match it up. So if 5.77 is my A, well, A is my starting value. It's my starting value or my initial amount. So look at your answer choices. Which one basically says it's your starting value or your initial amount? A, right? Because again, remember, this thing started in 1940. Okay. Any questions on that? All right. Keep chugging. SAT number 30, another exponential. Radioactive substances decay over time. True statement. We hope so anyway. The mass m in grams of a particular radioactive substance d days after beginning of an experiment is shown in the table to the right. If this relationship is modeled on the function m of d equals a times 10 to the bd, which of the following could be the values of a and b? Alright. So they're telling us m of d is a times 10 to bd. So again, if I think about this in terms of my exponential equation, A is out front, just like it normally is, so A is going to be my starting value, or my initial amount. Go to your table. What's your starting value, or your initial amount? What do you see in the data table for your starting value? 120, yeah. Like, how much of this radioactive sludge are we starting with? So A is going to be 120. We know that from our table. Okay. All right. Go to your answer choices. What can you get rid of?
A and B.
A and B are done. Get rid of them. Knock them out. Which means we only have two choices left for B. B is either positive 0.0022 or negative 0.0022. Okay. We just don't know which one. So pick one. Let's pick the positive value, plug it in. So if we pick the positive value and plug it in, then our equation becomes A is 120. B, we're going to try the positive value. And we're going to see what happens. Okay? So I'm going to pick a data point out of my table. I don't want to use the 0 because that's going to wipe out my exponents. That's going to be a problem. So I'm going to use the 30 for D and the 103.21 for M. So I'm using that second data point. I'm going to see if my equation works. So, if M is 103.21, is that equal to, this is 30. So I filled in 30 for D and 103.21 for M. So I just want to calculate the right side and see if it gives me 103.21 or something reasonably close. If I get like 102.9 or like 103.7, I'm going to call it good enough within rounding error. So throw that through your calculator, which I had out here momentarily. I had here a minute ago. I didn't. wind up with for this side, roughly? Yeah, in the neighborhood of 140, like 139 point stuff. 139.695, blah, 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 blah. Okay. That's not that close. No. So I would call that a fail. It's not C. So it better be D. Okay, so let's check D. So D would say that 103.21 is roughly equal to 120 times 10 to the negative 0.0022 times 30. So 10 to the negative 0.0022 times 30. Multiply that by 120. Yeah, 103.08, I think. 081. So that is nice and close. We'll take that for sure. So answer's got to be D. Okay. Questions on that? All right. So that's kind of how we figure that out. All right. SAT number 26. Oh, poor Keith. Keith modeled the growth over several hundred years of a tree population by estimating the number of trees' pollen grains per square centimeter that were deposited each year within layers of a lake's sediment. In other words, the poor guy is studying mud. He's doing a job. He estimated there were 310 pollen grains per square centimeter the first year. The first year. Does that make 310 your A, your B, or your X?
A.
A, yeah. So right away we know that A is 310. Okay? So pull that out of your problem immediately. Okay, so 310 pound grains per square centimeter the first year the grains were deposited with a 1% annual increase. If we are increasing, is B greater than 1 or less than 1? It's going to be greater than 1. Yeah, we don't know what it is, but we know it's at least greater than 1. Okay. All right, so we're getting data. 1% annual increase in the number of grains per square centimeter thereafter. Which of the following equations models P of T, the number of pollen grains per square centimeter, T years after the first year the grains were deposited? All right, so that's the data I have. Let's see if we can put our equation together, at least a little bit. Okay, so we know A should be 310. We don't know what B is, but we do know whatever's in here has to be greater than 1. So which equation, which answer has this form with a number greater than 1 in your blank? D, it's the only one, so it's got to be D. Again, I don't worry about calculating this, I just know that it has to be greater than 1. All right, bottom of the page, last one. The first year, Eleanor organized a fundraising event. She invited 30 people. For each of the next 5 years, she invited double the number of people she invited the previous year. So if F of N is the number of people invited to the fundraiser N years after Eleanor began organizing the event, which of the following statements best describes F of N? Okay, so if she's doubling the number of people, is she increasing or decreasing?
Increasing.
Increasing. So look at your answers. What can you get rid of?
A, C.
A and C, they're both decreasing. Get rid of those. 2 down. All right. We're down to a 50-50 shot. We haven't even done any math. If she's doubling the number of people, is that a pattern involving multiplication or is that a pattern involving addition? I think I heard both. Okay, so think about this. We want to do the same thing every year. Is she adding the same number every year or is she multiplying by the same number every year? She's multiplying, right? She's multiplying by 2 every year because she's not adding the same number every year. So it can't be a pattern involving addition. It's got to be a pattern involving multiplication. So if your pattern involves multiplication or division, it has to be exponential function. If your pattern involves adding or subtracting, then it's a linear function. That's how you tell the difference. Okay. So this one has to be increasing and exponential, which is D. All right. Next. Getting there, guys. It's 20 pages, we're on page 7. We're moving. Extraneous solutions. Everybody's favorite. Extraneous solutions are numbers that, so you solve a problem, you get your answers, okay? So they look like answers, but you plug them back in and they don't work. Those are extraneous solutions, okay? They're a pain in the butt. In school, you're going to encounter them in 3 places. On these tests, you only encounter them in 2 places. So the 2 places we have to watch out for on these tests are with what we call radicals and rationals. Radicals are anything involving a square root. So if your original problem has a square root in it, you know you might have an extraneous solution, and you have to plug your answers back in and check them. Okay. The other one is a rational equation. If you look at SAT number 28, which is the bottom problem on this page, that's a rational equation. It's got letters in the denominator. Okay. If you have letters in the denominator, again, you know you have to plug your answers back in and check. Okay. Those are the 2 areas where you have to check your answers for extraneous solutions on the test. The 3rd place you're going to run into extraneous solutions in school is in log problems. Problems involving logarithms. Okay. You don't have to worry. We will encounter log problems on these tests. However, they will not have extraneous solutions. Okay. All right. Any questions about what an extraneous solution is, concept-wise? All right, now let's look at actually solving them. So we're going to do an example first, then we have 2 problems to do. Well, I don't, you guys do. Okay, so we're going to solve a radical problem. So our radical problem, this is your example kind of in the middle of the page, is 2x minus 1 equals root x minus 8. I think I said x minus 8. It's 8 minus x. I'm dyslexic. All right. So the first thing to do in any root problem is to isolate the root, because again, that's your problem child. Isolate it. It's already isolated. That step's done. Okay. Next step is to get rid of that root. You get rid of the root by squaring it. I'm going to square both sides. Okay, right side is easy. The root and the square just cancel. This is 8 minus x. The left side. Do not distribute that exponent, people. That is breaking a math command. Thou shalt not distribute thy exponents. Okay, on the left side, what this really means is 2x minus 1 times 2x minus 1, and you must FOIL. Okay. So, FOIL the left side, we get 4x squared. Minus 2x, then minus another 2x, so it's minus 4x, and then plus 1. Okay. This is a quadratic. Anytime we have both an x squared term and an x term, that means you're going to have to factor. So push everything to one side. We're going to move the 8 and the x to the other side, and then factor. So I'm going to subtract 8 and add x all at the same time. So 4x squared, if I add x, negative 4x plus 1x is negative 3x. Subtract 8, 1 minus 8 is negative 7, equals 0. And then I have to factor that beast. You guys can factor any way you want to factor. Okay, I don't care if you do guess and check, slide, AC method, box method, whatever floats your boat. However you've learned to factor is fine, as long as you can do it quickly. For those of you who don't remember how to factor, I'm going to do the AC method here. I'm going to teach you guys both the AC method and the box method when we hit factoring. So that way you have 2 choices. So the AC method goes like this. You take A, 4, times C, negative 7. So A times C is negative 28. I need factors of negative 28, now work right to left, that subtract to give me negative 3. So in other words, my signs are going to be different, and I got to come up with negative 3. So 1 times 28, 2 times 14, 4 times 7. This is where it pays to know your multiplication tables. Again, I need my signs to be different. I got to come up with negative 3. 4 and 7 are going to do that for me. If If I have a positive 4 and a negative 7, that's going to give me a negative 3. Okay. Once you have your combo that gives you that middle number, you're going to replace that middle number, that negative 3x, with the two numbers you just found. So 4x squared, and then instead of writing negative 3x, I'm going to replace it with these two. Order does not matter. I'm just going to do it in the order we have it written. So plus 4x minus 7x. And then I still have this minus 7 here. Okay. And then I'm going to factor by grouping. So I'm going to take my first two terms and pull out my GCF, my greatest common factor. So 4x squared and 4x, the biggest number that goes into both of those is 4. And the number of x's I can take out is just 1 because my second term only has 1x. All right, divide your numbers, subtract your exponents. 4 divided by 4 is 1. X squared divided by x is just 1x. Next term, 4x divided by 4x is just 1. Okay. On to your next set. Negative 7x minus 7, the biggest number that goes into both of those is 7. Because this first term is negative, I have to pull a negative. I don't care about the second one. The first one's negative, I pull a negative every single time. So I'm going to pull a negative 7. Again, divide by numbers, subtract by exponents. Negative 7 divided by 7 is just x. Negative 7 divided by negative 7 is plus 1. If your parentheses match, you have done it correctly. If your parentheses don't match, you need to look for a boo-boo. Pull your parentheses out front. If it makes it easier for you to see what's left, cross them out. What you have left is 4x minus 7, and that's your second set. Again, this is called the AC method. It's one method of factoring. I'll show you box method when we go to do factoring. Okay. Now that we have this sucker factored, we're going to do what we always do when we have something factored. We're going to split it up. So either x plus 1 is 0 or 4x minus 7 is 0. So x is negative 1 or x is 7 over 4. Those are my two possible solutions. Okay, I'm going to get rid of this. All right, now that we have our two solutions, we can actually check to see if they're extraneous, which is what this problem was really about. So to see if they're extraneous, we're going to plug them into our original problem, which is 2x minus 1 equals root 8 minus x. So I'm going to check the negative 1 first. I'm going to plug negative 1 into both sides. I'm going to get 2 times negative 1 minus 1 equals root 8 minus negative 1. There. All right. So 2 times negative 1 minus 1, that's negative 2 minus 1, that's negative 3. 8 minus negative 1 is 8 plus 1, that's 9. Square root of 9 is just 3. Negative 3 is not equal to 3, which means negative 1 is extraneous. Always be kind of suspicious of your negatives and your zeros. They tend to be the extraneous solutions. Not always, but they tend to. Okay. Now, to save time and effort, if you plug in 7 over 4, I'm just going to tell you it works, okay? I would do that with a calculator. This is a solution. Okay. Now, in school, what we would normally do is toss the extraneous. We just cross it out, it's done, it's gone. You don't want to do that on these tests. Sometimes they will actually ask you for the extraneous solution. So if they ask you for the extraneous one, you give them negative 1. If they just said, what's the solution to this problem, you give them 7 over 4. Okay, so just give them whatever they ask for. Questions on any of this monstrosity? Okay. The next problem there is yours to do for homework, SAT number 29, but let's talk about it for a minute. In this problem, they're asking you to find the extraneous solution. Normally, if we have numbers in our answers, what do? What's our go-to strategy with numbers in our answers? Plug them in. That won't work in this case. Why will it not work? Because it's extraneous. We're looking for something that doesn't work. okay? So you're plugging your answers in, but you're looking for something that doesn't work. How do you know when it doesn't work if it's an extraneous solution or if it's just something that doesn't work and it's just a wrong answer? You don't know. You don't know the difference. So anytime that they're looking for the extraneous solution, you have to actually do the work. You have to actually do the algebra, find the solutions, and see which one's extraneous. Okay, SAT 28, the one at the bottom of the page, is also yours to do for homework. However, in that problem, they're looking for the solution. They're looking for the one that works. If you're looking for the one that works, what can you do with your answers? Plug your answers in. Just plug your answers in, find the one that works. Okay? So you can take the shortcut on that one. All right. Functions. Functions. All right, so we have two types of function problems. We have our normal function problems, and then we have our funky function problems. The funky function problems are only on your SAT. We're going to deal with the normal function problems first, because those are all tests. The normal function problems, for the most part, are stuff you see at school. Okay. SAT number 3. If f of x equals x cubed minus 4x plus 8, then what's f of 5? All right, what are you going to do with 5, guys? Yeah, just plug it in for x. Okay. So if f of x is x cubed minus 4x plus 8, and we want to find f of 5, the 5 is taking the place of the x. You can really see it if you line it up. So plug it in for x. And then just run that through your calculator. Just calculate a problem. What do you get? 113. That's your answer. Good. Okay. Alright, so sometimes these problems ask you to plug in for x, like this one. Sometimes they ask you to plug in for f of x, in other words, y, which is the left side. So you got to be careful as to what you're plugging in for. Are you plugging in for x, or are you plugging in for f of x? So let's look at number 11. If f of x, bless you, if f of x is x squared plus 2, which of the following could be a value of f of x? So which side am I plugging in for? Now I'm plugging in for the left. I'm plugging in for f of x. Okay. All right, so for this guy, I've got f of x equals x squared plus 2. Okay. I know they're asking me which of the following could be a value of f of x. I know one of my answers, A through D, is f of x. One of these answers is the left side. But I don't know which one. So I'm just going to pick one and plug it in. What are my choices? Let's try 0. I like 0. So if 0 is on this side, then I have 0 equals x squared plus 2. Let's see if I can solve for x. Subtract 2. Square root both sides. Uh-oh. Can I take the square root of a negative number and get a real answer? No, that fails. Okay, that doesn't work. So 0 is not my answer. Pick another one. Where do you want to go next? Negative 1. All right, let's try negative 1. So negative 1 equals x squared plus 2. Subtract 2. Negative 3 equals x squared. Root. Same problem. Can't take the square root of negative 3. So negative 1's out. Where do you want to go? D. 2. 2 equals x squared plus 2. Move the 2. 0 equals x squared. I get square root. I can do that. The square root of 0 is just 0. That's allowed. So my answer is D. It's the only one that works. All right. ACT 21. These are what we call composite, or sometimes they're called nested functions. I think they're using the word composite more these days. Given functions f of x equals 2x plus 1 and g of x equals x squared minus 4, what is the value of f of g of negative 3? So we're looking for f of g, fail, f of g of negative 3. Okay. And we know f of x is 2x plus 1. and g of x is x squared plus 4. Okay. Go. All right. Anytime you have multiple sets of parentheses, when you're doing PEMDAS, when you're doing order of operations, you always start from the inside and work your way out. Composite functions are no different. We're going to start on the inside and work our way out. So my inside function right here is g of negative 3. Let's start there. So g of negative 3. So g of negative 3, plug negative 3 into g. I'm going to get negative 3 squared minus 4. Negative 3 squared is 9. 9 minus 4 is positive 5. Okay. So that means my inside, g of negative 3, is just 5. So now I have f of the inside, which was just 5. So f of 5, you're just going to plug 5 into f. So that's 2 times 5 plus 1, which is just 11, and that's your answer. You're done. Okay, so composite or nested functions really are nothing to be worried about. You just do them in 2 stages, the inside and the outside. Don't let them mess with you. All right, bottom of the page, ACT number 43. If f of x equals x squared plus 3x and g of x equals x plus 1, what is the value of f of g of x? Okay, so f of x was what? X squared plus 3x. X squared plus 3x. G of x was other stuff, x plus 1. So we're looking for f of g of x. Okay. You have letters in your answers. What do we do with letters in our answers? What's our go-to strategy? Plug in a number. So pick a number for x. Pick a number, guys. Pick a number. 2. I like little numbers. Okay, so x is 2. This now becomes f of g of 2, and it's just like that problem over there. Okay. Inside first and then outside. So g of 2 is 2 plus 1 is 3. So inside function is 3, so now I have f of 3. That would be 3 squared plus 3 times 3. That's 9 plus 9, that's 18. Okay, goal is 18. That's my target. All right, you chose x is 3. So plug 3 into your answer choices, A, B, C, and D, and see who, not 3, you chose x is 2. Beg your pardon. Plug 2 into your answer choices and see which one gives you 18 as a result. Okay, so take a minute, calculate your answers out, see which one gives you 18. And I chose 2 when I did this problem, so I will tell you there's only one that works. That works too. What did you get, guys? A. Yeah. You can definitely also, if you know how to like plug one function into the other and do the algebra, you're welcome to do that as well. I just see a lot of students who can't do that or have trouble remembering how to do that. So this is your alternative. Okay. We are leaving normal function questions. We are moving on into funky functionville. So these are SAT only questions. Next two, number 20 and number 15. So number 20, let the function g be defined by g of x equals 5x plus 2. So far, so good. If the square root of g of a over 2 is 6, what is the value of a? What just happened? Okay. Where did that just go off the rails? All right, so what did they give us here? They gave us the square root of g of a over 2, and they want that to come out to be 6. All right, cool. What is the value of a? Well, I have numbers in my answers. So that means one of those numbers that they gave me is the value of A. Now, I don't know about you guys, but I want to avoid answer choices A and B as long as possible. I don't feel like plugging in roots. So let's try C first. And let's get a decimal. So answer choice C is 34 over 5. Okay, so answer choice C is 34 over 5, which is 6.8. Now it says what is the value of A, right? Which means that 6.8 is actually A. Okay, where is the only place in this problem that I can plug in A? No, I can't plug in X because it didn't say what is X. It said what is A. This is A. Where's the only place that I can plug in A? Yeah, over there. It's the only place that has an A. So let's go in there. The only place it can go. So that's going to be the square root of G. 6.8 over 2 is going to be 3.4. And again, we're hoping that this is going to come out to be 6. We hope. Because then that would mean I have the right answer. So how do I figure out what G of 3.4 is? Yeah, that 3.4 is going to go in here. Because this is G of X. So G of 3.4 can go in here. So 5 times 3.4 plus 2 is something I don't know. This is 19. So that's 19. So is the square root of 19 equal to 6? No, that fails. Okay. So C was not my answer. Again, wishing to avoid A and B as long as possible, let's try D. So D was 68 over 5, which is 13 point something, 13.6. Okay, so again, the only place it can go is A, so it's going over there. So square root of G of 13.6 over 2, and I'm hoping this comes out to be 6. 13.6 over 2 is 6.8. So now I got to plug in 6.8 into G. So G of 6.8 equals 5 times 6.8 plus 2. What's 5 times 6.8 plus 2? Is 36. Cool. So if that's 36, the square root of 36 is indeed 6. And my answer is D, and I don't have to go plugging in those roots of A and B. Any questions on this? This is your funky function problems. All right, next one's yours for homework. It's another funky function problem. So 15 is yours. If f of x is equal to x squared minus 4x plus 10 and c is a positive integer less than 5, what is one possible value of c? One possible value. That is trying to clue you into the fact that there's more than one right answer. Okay, so f of x is x squared minus 4x plus 10. C is a positive integer less than 5. Cool. Pick a positive integer less than 5. 4. C is now 4. All right, if C is 4, what is the value of f of C or f of 4? So f of 4, just plug in 4. You're going to get 16 minus 16 plus 10, which is 10. So your answer would be 10 if you chose 4. You have 4 different right answers to this problem. Okay? Because you could choose 1, 2, 3, or 4 for C. That's going to give you 4 different values for f of C. Any of those 4 answers would be correct. They do this a lot on Griddon, so there's more than one right answer. Alright, next one on the page there, at the bottom, gridded number 20. The function f is defined by f of r equals r minus 4 times r plus 1 squared. If f of h minus 3 is 0, what is the possible value of h? Alright. So f of r is r minus 4 times r plus 1 squared. And we want f of h minus 3. Okay, so f of h minus 3, this is no different than having like f of 4. What do we do with the 4? We plugged it in for x. What are we doing with the h minus 3? We're going to plug it in for r. Just because it's letters doesn't make it any different. So, plug it in for r. We're going to get h minus 3 minus 4, h minus 3 plus 1, quantity squared. Now let's just clean it up. H minus 3 minus 4 is h minus 7. H minus 3 plus 1 is h minus 2, quantity squared. Okay. From the problem, we know that once we plug this in, it says that it's equal to 0. It says if f of h minus 3 equals 0. So we know this is equal to 0 at this point. Okay. What's the possible value of h? So basically they factored it for us. We just have to solve for h. So split it up. H minus 7 equals 0. H minus 2 equals 0. Which means h is either 7 or h is 2. And again, you have two possible answers. Either one would be correct. Yeah.
Wait, why isn't the 2 squared?
So when you have a squared on the outside, another way to write this is h minus 7 times h minus 2 times h minus 2. It just means that I have two h minus 2's. Okay, so you just wind up with h is 7, h is 2, and h is 2. So either way, your roots are still 2 and 7. Good question, though. I get that a lot. Okay, before this next section, let's take a break.